Welcome, everyone. I'm absolutely thrilled you're here today because we've got a truly fascinating explainer lined up. We're going to map out the entire global semiconductor industry. Now, you might not see them, but these chips are the invisible foundation of our modern world. In fact, they're literally the most complex objects ever manufactured by human hands. Everything from that smartphone in your pocket to the massive AI systems completely transforming our economy, it all comes down to silicon. By the end of this explainer, I'm going to reveal what I like to call the rule of three. It's basically the holy trinity of companies that effectively control this entire global ecosystem. I promise, you won't look at your electronics the same way ever again. Okay, let's dive into this. Here is our roadmap for today. First, we'll cover the silicon ecosystem. Second, the different types of chip companies. Third, we'll look at the global supply chain. Fourth, careers and investments. And finally, we'll break down those ultimate power players.
All right, Section 1, the silicon ecosystem, moving from idea to reality. So, what we're looking at here brilliantly illustrates the incredible interconnected journey of a single microchip. It isn't just one company building a product in a vacuum. It's more like a massive global relay race. Step 1 usually kicks off with design, heavily based in the United States. Step 2? Well, that requires highly specialized manufacturing tools that largely come all the way from the Netherlands. And then Step 3, the actual physical fabrication, predominantly happens over in Taiwan. Just to put the sheer scale of this into perspective, building a single modern fabrication plant, or a fab as they call it, can cost upwards of $20 billion. So yeah, it requires massive, unbelievable global cooperation to build our modern tech stack.
Moving right along, Section 2, types of chip companies. Let's define the actual business models here.
Let's start with what we call fabless companies. The best way to think about this is using an architect versus builder analogy. Fabless companies, they're the brilliant architects. They're sitting there drawing up these incredibly complex blueprints for the chips, designing the logic circuits, the AI pathways, the mobile processors. But they don't actually build them. They completely outsource the physical manufacturing part of the job. Some huge names fall into this bucket. Think NVIDIA with their AI chips, Qualcomm with Snapdragon mobile processors, plus other giants like AMD, Broadcom, and MediaTek. They focus entirely on innovating the design, completely skipping the massive multi-billion-dollar overhead of running a factory.
So the crucial point here is, if the fabless companies are the architects, well, who are the builders? Those would be the foundries. Foundries are essentially the construction crews, pouring the concrete and doing all the heavy lifting to bring those intricate blueprints to life. They don't design the chips at all. Their entire business model is just fabricating chips that were designed by somebody else. TSMC is the undisputed king here. They're the world's largest chip manufacturer, working right alongside other major players like Samsung Electronics and Global Foundries.
Finally, we have the IDMs, which stands for Integrated Device Manufacturers. Now, these guys do it all. They act as both the architect and the builder, all under one single roof. They handle the entire process completely in-house, designing their own chips and then turning around and fabricating them in their very own factories. Classic examples of IDMs include Intel with their CPUs, Texas Instruments doing analog chips, and memory giants like Micron Technology and SK Hynix.
So, if we really distill this whole thing down, on one side you have the brains. These are the pure chip designers, the innovators driving high-performance computing and AI architecture, companies like NVIDIA and Qualcomm. And then, on the other side, you've got the brawn. These are the manufacturers, the absolute masters of the impossibly complex physical fabrication process, like TSMC and Samsung. This exact split in labor and specialization, that is the defining characteristic of the entire modern semiconductor industry.
Which brings us to Section 3, the global supply chain. Let's look at the geopolitics of silicon.
If we take a step back and zoom out to look at this on a global scale, we see something truly incredible. The industry is heavily, deeply siloed by specific nations. The United States absolutely leads the pack in design, AI, and high-performance computing, with those companies like NVIDIA and Intel. Then you have Taiwan, which is the absolute manufacturing powerhouse, completely dominated by TSMC. South Korea is the undisputed king of memory chips with Samsung and SK Hynix. Over in Europe, the Netherlands supplies the ultra-essential manufacturing technology. And right now, India is rapidly emerging as a massive, massive source of chip design talent. You can really see how dominance in this industry is literally sliced up on a country-by-country basis.
Now, what's really interesting here is when we zoom in on the Netherlands, we find essentially one country and honestly one specific company holding the ultimate keys to the kingdom, ASML. They hold a near monopoly on EUV or extreme ultraviolet lithography machines. These machines use light wavelengths so impossibly small that they are literally printing features onto chips at the atomic level. It's mind-blowing. Without ASML and their EUV equipment, manufacturing today's advanced chips is simply impossible. No exceptions. They provide the highly specialized tools that allow the foundries to even do their jobs.
Let's pan over to South Korea for a second. While Taiwan dominates the foundry space like we talked about, South Korea has an absolute stronghold on memory chips. Companies like Samsung Electronics and SK Hynix are producing the vast majority of the world's DRAM, which is basically the short-term working memory, and NAND, the long-term storage. Now, why does this matter so much right now? Because memory chips are absolutely critical for powering modern data servers. They are the essential fuel for the massive, data-hungry demands of this huge AI boom we're living through.
All right, moving into Section 4, Careers and Investments. Let's navigate the industry.
So how do you actually get involved? Career paths here cleanly separate right along the lines of those business models we just discussed. You have design and VLSI roles. That's very large-scale integration, literally fitting billions of transistors onto a single chip at those fabless giants like Qualcomm and NVIDIA. You've got product and systems roles at IDMs like Texas Instruments. But what's incredibly exciting right now is the massive, rapid growth in services and India-based opportunities. Driven by the Make in India government push and just an incredible pool of design talent, companies like Tata Electronics are actively building fabs, while giants like TCS, Wipro, and Infosys are absolutely booming in semiconductor services, chip verification, and embedded systems.
From an investment angle, tracking widely followed stocks like Micron, AMD, or TSMC tells a fascinating story. Historically, semiconductor stocks were highly cyclical. That basically means they suffered from sharp boom and bust cycles depending on how much consumer demand there was for electronics at the time. But look at what is happening right now. The incredible, honestly, insatiable demand for AI technology is actively changing that historical dynamic. It's completely pushing companies like NVIDIA into extreme, uncharted high growth and high valuation territory. It's a real game changer.
And that brings us to Section 5, time for the ultimate power players, the rule of three.
First up, delivering on that promise from earlier, the single most powerful company right now is undeniably NVIDIA. As a fabless chip designer, they have captured the absolute lion's share of this massive AI boom. Their specialized AI and GPU chips are the literal engines driving today's technological revolution, and that's resulted in unprecedented growth and just staggering valuations. They are the architects defining our future, for sure.
Next on our list, we have the most important company globally, TSMC over in Taiwan. Remember, those fabless designers like NVIDIA and AMD, and even massive tech giants like Apple, they don't build their own chips. They rely entirely, 100%, on TSMC. TSMC is the stable, reliable manufacturing backbone of the entire industry. Seriously, if they stop producing, the global tech economy grinds to a sudden and brutal halt.
And finally, concluding our trio, we have the most irreplaceable company, ASML in the Netherlands. Think about it, even TSMC cannot manufacture advanced chips without the highly specialized tools that only ASML can provide. Their near monopoly on those EUV machines makes them the absolute critical choke point of the entire tech world. They are truly, utterly irreplaceable.
So we've seen how perfectly these nations and companies fit together, right? US design, Dutch tools, Taiwanese manufacturing, Korean memory. It's like a giant, beautiful puzzle. But I want to leave you with a final provocative thought today. What we are looking at is a highly interconnected, massively complex global assembly line. So what happens if a single link in this incredibly fragile global chain breaks? What happens to our AI ambitions, our economies, and literally our daily lives if just one of these specialized players steps out of line? It's a geopolitical puzzle with the highest stakes imaginable. Thank you so much for exploring the silicon ecosystem with me today.